We're going to be talking about the graphs of rational functions. So when we're talking about a graph of a rational function, most of the time what we're looking for is something in the form of g of x equals a over x minus h plus k. So the h and the k we've seen before with parabolas and that kind of stuff. The h is going to represent your shift left and right. Your k is going to represent your shift up and down. And then a is just some number, it's some constant number. Again, this is just going to tell us where everything is moving in terms of our rational function. So for the first example, we're going to rewrite to identify our asymptotes based on that equation right there with the g of x. So with that being said, we are going to have 3x divided by x plus 2. So when we're talking about rewriting to identify the asymptotes, what it means is you need to have a number, aka the a, without any variables. So like I can't have this x right here. So I have to rewrite it. And in order to do this, we're going to use long division. It's not as bad as you think. So that 3x is being divided by x plus 2. So using our long division, you can think of this as, okay, 3x divided by x gives me the 3. Distribute that, and I can see here that I get a remainder of -6. Okay, so how does this help me? This helps me because my function is now going to be in the form of g of x equals 3 minus 6 divided by x plus 2. And the reason being is because that 3 comes out here, and my remainder, we know, is technically -6 over x plus 2, which is just showing you the equation we have. So based on our new equation here, our new function, we can then decide, okay, well, we know where the shift is going to occur, okay? So looking at this, we are going to shift up 3, and we are going to shift to the left 2. Now remember that it's the opposite of what you see for that h. The -6 just represents some a value, so let's double check our graph to make sure that we in fact have this correct. So go over to Desmos and notice it's the red one. I did in fact go up 3 and shift to the left 2. So if I'm basing it off of this, that's going to identify my horizontal and vertical asymptotes. So looking at that graph, the shift up 3 is going to identify the horizontal, and the left 2 is going to identify the vertical. So that's rewriting our equation, but you can do this without rewriting. Say for instance, sorry, got interrupted there, but you might not be able to use long division in order to rewrite your equation in that special form. So there's tricks that you can do in order to identify your vertical asymptotes and horizontal asymptotes. So looking at this first one, we're just going to look at finding the vertical asymptotes. So let's say that we have 4x plus 1 over 3x squared plus 14x plus 8. So what you're going to do is you are going to set the denominator equal to 0. And the reason being is because, like I've mentioned before, vertical asymptotes occur when the denominator is undefined, aka 0. Okay, so 3x squared plus 14x plus 8, set equal to 0. Check. Step 2, factor. It always comes back and we factor. If it's an x squared term, we're going to be using the AC factoring. Just a little side note, I guess, over here is I'll factor this quickly. My A is 3 and my C is 8, so I'm looking for the factors of 24. One and 24, 2 and 12, 3 and 8, 4 and 6. It's going to be my 2 and 12. So factoring this quickly, and I'm going to get 3x plus 2 here, and between the 12 and the 8, it's a 4. So I've got 3x plus 2 and 3x plus 4. So from here, I factored it. Step 3 is then going to, figure out what is each set of parentheses, what is each factor equal to 0. When we're setting those equal to 0, that's going to give us the location of our vertical asymptote, so long as the numerator does not have the same factor. If the numerator has the same factor, then it's not actually a vertical asymptote. Instead, it's a hole. So we didn't have, looking at our numerator, 4x plus 1 did not occur. So these here are going to be our vertical asymptotes. So step 4 is to double check for cancellation a numerator factor, which we in fact did not have. Horizontal asymptotes are a little bit different. They're a little bit trickier in the terms of you kind of need to know what a graph looks like for a rational function or different types of functions. So let's say that we have 3x cubed minus 3 over 6x squared plus 7x plus 1. So what you're going to do is you are going to take the highest degree term on the numerator and denominator. So if I'm doing that, what that means is I can cross off or cancel everything else that is not the highest degree. So like I'm going to cancel out that negative 3. I'm going to cancel out this plus 7x plus 1. Now I'm looking at this 3x cubed over 6x squared. So step 2 is to reduce. So if I'm reducing this, this is going to go down to 1/2 x. Okay, so step 3 is what is the end behavior for this reduction? So looking at this, I have a 1/2 x. which I know is really just like in the form of y equals mx plus b. So if I'm thinking about this, this graph of a half x is going to look like this. So looking at this, I actually don't have any horizontal asymptotes for this function because it keeps going on forever. So it's going to negative infinity here and positive infinity here. However, so we don't actually have any, but there might be times when it actually cancels out to be just a number, such as a half. And that right there is going to be your horizontal asymptote, and this is going to give you the trick of the trade in order to do this quickly and without a graph.